Welcome back to my channel, and in this video we are going to learn insertion in BST but for odd order. So there are basically three rules to follow. The first one is minimum keys. That means when you are having a B tree like this, suppose, so the children of this tree are this. Okay, it still has children. So these are all the children of the B tree. It acts like a root node, and the keys are the small elements in it. Okay, so the minimum keys in every single array, they has to be m minus 1. M is nothing but the order. Since we are talking about the odd order, so they are like 1, 3, 5 and so on. So minimum keys would be m minus 1, maximum keys are 2m minus 1. So any child cannot have more than 2m minus 1 keys, and maximum children is nothing but 2m. So in this case, to reduce the overflow condition, what is the overflow condition? See, suppose I am taking an order of 3. So what would be the maximum keys here? 2m minus 1. So that is 2 into 3 minus 1. So that is 5. So 5 elements can be inserted in the following child box. 1, 2, 3, 4, 5. Okay, if you insert the 6th element, then this would cause an overflow condition. So to reduce it, the middlemost element, this is 1, 2, 3, 4, 5, 6. So 6 by 2 is 3. So the third middlemost element would get inserted, would go to the top. So now this would split into two parts. Okay. Now let's see with an example so that you'll have a clarity. Insert the elements in B tree of order 3, and these are all the elements to insert. So first you'll have to remember that after inserting, you'll always sort the array. No matter how many elements you'll sort, you'll check the condition, like is it satisfying all the three conditions of minimum keys, maximum keys and maximum children, and then you need to also reduce the overflow condition. So the first element to insert is 10, and here the order is 3. So what would be the maximum keys? It is 2m minus 1. That is 2 into 3 minus 1. So this comes out to be 5. What is the minimum keys condition? It is nothing but m minus 1. So it is 3 minus 1, 2. What is the maximum children? It is 2m. Nothing but 2 into 3. That is 6. Okay. Now the first element to insert is 10. So what is the maximum keys we can insert in a child? That is 5. So we'll first create a box which has 5 keys. 3, 4, 5. So first element is 10. Now next element to insert is 20. Next element to insert is 5. But now we need to sort this array. So now this would become 5, 10, 20. Okay. Now the next element to insert is 6. Now we need to again sort the array. So this would come out to be 5, 6, 10, 20. Now the next element to insert is 12. So after inserting 12, we need to again sort the following array. Okay. So now this comes out to be 5, 6, 10, 12 and 20. Now the next element, when we insert it, that is 30. Now this has caused an overflow condition because the maximum keys that can be is only 5, but here there are 6. So this would now get split into 2 parts. See, you need to split the part which is like the only maximum keys one. You shouldn't add this extra part. You should only split the exact part which you are having, like the maximum keys one which you are having. You need to only split that thing. Don't include this one. This is only to check that overflow condition has occurred. You can't directly insert an element here like this. So what you do, you split the middlemost term, that is 10. So now 10 would go to the top with 5 keys, 3, 4, 5, and left of 10 we are having 5 and 6. So they will be over here. And right side of 10 we are having 12, 20 and 30. Okay. Now the next element to insert is 7. So 7, it would be left of 10. So you always come from top and go to the bottom. So it would be left of 10. So here. And these are all sorted. So there is no need to sort it again. So the next element to insert is 17. It would be right of 10. When you insert it here, now it needs sorting because they are not in a specific order. So you sort them first. So after sorting, this would look something like this. And after that, the next element to insert is 3. So it would be left of 10. When you insert it over here, it again requires sorting. So we'll sort the array again. Now this would come out to be like this. Now the next element to insert is 25. So it would be right of 10, and when you insert it to the right side of 30, now it again requires sorting. So the final B tree looks like this. 10 over here, left of 10 there is 3, 5, 6 and 7, and right side of 10 we are having 12, 17, 20, 25 and 30. So this is our final B tree. Remember, when you split a node, see, you should only consider the first maximum keys part. Don't include this one. But the one thing you should remember is you need to split it after you sort them. See, after you, suppose in this case, I have to insert an element 7, suppose. Then I'll first sort them 5, 6, 7, and then comes 10, 12 and 20. Okay, like this. After I sort, I have known that this is an overflow condition. So you will reduce this part, the maximum keys part, and now here the 7 would go to the top. Don't include this extra one, only take the maximum keys part. That's it. You should only remember this, and the rest is you need to do it normally. And I have